Before starting to configure the data logger NanoSUM, it is necessary to connect it via USB to the computer and install the drivers provided at the time of purchase. Without this operation, it will not be possible to communicate correctly with the device through the DAK software. Once the drivers are installed, in device management, the data logger will be recognized as a modem. Note the COM port assigned to the two new devices by entering their respective properties and clicking on Advanced Port Settings. Let's open DAK and select the NanoSUM model from the target menu. This enables all the device-specific features. Next, we check which COM port has been assigned. We can start from a new configuration by clicking on File, then on New. Inside the project, we encounter the main sections. Let's start with the parameters. Among the first items, we find the station ID, which uniquely identifies the data logger on the network. Moving on, we access connection parameter. Here, we need to enter the APN of the SIM card used, essential for data transmission via FTP. The IP address remains on IPv4 and should not be changed. We also find the NTP setting for clock synchronization. The server is already pre-configured, but the time offset must be set correctly. Note, the offset is not expressed in hours, but in quarters of an hour. So for GMT +1, you need to enter the value 4. A very important parameter is the watchdog on FTP sending. It ensures the system operates even in case of malfunctions. If the data logger fails to send data for 1,440 minutes, that is, 24 hours, it automatically performs a reset. We can also set a password for access via SMS. By default, it is 1, 2, 3, 4, and can be changed for security reasons. There is also a logging function via USB port. If activated, diagnostic messages are sent during operation that we can read in real time. We can choose to display only errors, only information, or all messages. Let's move on to the section dedicated to power management, the power supply management. Here we can decide whether to provide continuous or timed power to the external sensors. For example, we can program the power supply to activate only a few seconds before acquisition and deactivate immediately after to reduce energy consumption. Then, we set the operating intervals. We can choose how often to acquire the data, how often to store them, and how frequently to send them to the server. All these parameters are customizable based on the project's needs. Let's now enter the acquisition section, that is, data acquisition from sensors. Here we can connect MOD bus sensors, specifying the sensor address, the type of measurement, the number of decimals, and whether we want to apply an offset or a corrective formula. We can also choose the type of process. 1 indicates the arithmetic mean, 2 the trigonometric mean, useful for example for wind direction. 3 represents accumulation, suitable for rain, while 4 applies a statistically filtered mean. For each measurement, we can decide what to store. For example, we can store the instantaneous value, the average, the minimum, or the maximum. Code 3 allows saving both the snapshot and the average. We can also configure an alarm. Just enable the function, define the threshold value, set the hysteresis, and specify how many seconds the condition must persist before the alarm is recorded. One last advanced feature is the customization of the letters associated with the data. By default, the system uses standard letters, A for the instantaneous, B for the average, C for the minimum, D for the maximum. But if necessary, we can activate customization and use different letters to adapt to specific record tracks. Once all the configuration is completed, we can save it and send it to the NanoSUM by clicking on Send. The data logger will automatically restart to apply the new settings. For more details, please refer to the complete manual available on the manufacturer's website.